Using the above graph, find each of the following. You should assume that y equals 0 is a horizontal asymptote and x equal -4 is a vertical asymptote. Okay, so the first problem we have f of -2. So if we look at our graph here, we can see a hole where the graph meets as part of this piecewise function at x equal -2, but we also see that we have a value plotted at -2, 3. So in this case here, even though there's a hole at -2, 1, we do have the value defined at -2, 3. So the answer here would be 3. And then the second problem, we want the limit of f of x as x approaches -2 from the plus side, which means from the right. So when we have a problem like this, what we're going to do is we're going to find x equal -2, and then we're going to find the piece of the graph to the right of -2. So we're going to start from the right side of -2. So we're going to start with that piece with the negative slope, and we're going to follow that up until -2. And we can see that it stops at 1 and there's a hole there. Well, even though there's a hole there, that we can still have a limit. So the limit here in this case is 1. And then problem 3, we want the limit of f of x as x approaches -2. There's no plus or minus on here, so this is a two-sided limit. So we're going to look from the left side and the right side, and if they match, that means that the limit is going to exist, and it would be that value. So we already found out that as we approach -2 from the right, the answer is 1. But what happens when we find the limit of f of x as x approaches -2 from the left? Well, that's that piece of the horizontal line. And we can see if we follow that to -2, it also equals 1. So that means even though there's a hole there, the limit exists, and its answer is 1. Okay, the next problem we have, we want the limit of f of x as x approaches -1 from the right. So again, we're going to find -1. We're going to go to the right side, and we're going to follow the graph down. And we can see that it stops at y equals 0, so the limit here would be 0. And then we want, for number 5, we want the limit of f of x as x approaches -1 from the left side, from the negative side. So we're going to start this way. We're going to come down, and again, we get 0. So does the left-hand limit equal the right-hand limit here? And that's what we're looking at in problem 6. And we can see, yes, they both come out equal to 0. So that means the limit of f of x as x approaches -1 equals 0. Okay, problem 7, 8, and 9, we're going to be looking at the limits as x approaches 1. So the first one in number 7, we want to approach x approaches 1 from the right side, from the positive side. So we're going to go to the positive side of 1. We're going to follow the graph down, and we see that the answer is 1. For problem 8, we want the limit of f of x as x approaches 1 from the negative side, or from the left. So we go to the left of 1, we follow the graph, and we get 2. So does the limit of f of x as x approaches 1 exist? No, because the left-hand limit is 1, and the right-hand limit is 1, and the left-hand limit is 2, which means that they're not equal to each other, so this would be D and E does not exist. Okay, problem 10, we have f of 3. Well, if we go and look at x equal 3, we can see we have an open circle at 5. So the limit here does not, or f of 3 does not exist. The limit for problem 11, the limit of f of x as x approaches 3 from the right, we grab the piece of the graph from the right, we follow it up, and we can see that it stops at 5, even though it's not defined at 5, the limit still can equal 5. And then we do the limit from the, as x approaches 3 from the left, we start from the left side, we go up, and we can see that its limit value is also 5. So the key concept is that students need to understand is that the value can have a hole there, but we can still have a limit as long as the left-hand limit and right-hand limit are the same. Okay, if we continue from the right-hand and left-hand limits in the last two problems, then the limit of f of x as x approaches 3. Since they're both the same, they were equal to 5. That means our limit equals 5. All right, in problem 14, we want the limit of f of x as x approaches negative 4 from the right. So we have negative 4 from the right, and we can see that we are approaching the asymptote. We're going up here, so this would be positive infinity. And then 15, we want the limit of f of x as x approaches infinity. So as x gets increasingly larger, what's happening to the graph? It said in the instructions here that we have a horizontal asymptote at y equals 0. So this graph is approaching 0. Okay, problem 16, we have f of 1. So we go and look at x equal 1. And we can see we have a jump in the graph, but the value is defined at 1, 1. So the answer here would be 1. 17, we want the limit of f of x as x approaches negative 3. So again, we're going to look at the left-hand and right-hand limits. So the left-hand limit, the graph would approach 1 from the left side, and then from the right side, it's a horizontal line at 1. So in this case here, the left-hand limit and right-hand limit are the same. So the answer is 1. And then the final problem, we have f of negative 4. They told us that there is a vertical asymptote at negative 4. So in this case here, f of negative 4 is undefined. Okay, I hope that helps. That was 18 problems with finding limits using a graph. I try to give you every possible scenario that you can see on the graph. So I hope that helps, and please like and subscribe. Thanks for watching.